All right, let's keep going. So on Tuesday, we talked about two triangles being congruent. Okay, if two triangles or any two shapes really are congruent, then what do we know?
They have the same angle?
Okay, all the corresponding angles are congruent. What do I mean by corresponding? The matching.
Yeah.
Like this one goes with this one, this one goes with that. All the corresponding angles have to be congruent. What else do we know? All the corresponding sides have to be congruent, right? All these matching sides have to be congruent. So, if we know the triangles are congruent, then we know the matching parts are congruent. Basically, that's the definition of congruent triangles, right? Or you can say it backwards. On Tuesday we did a couple proofs where we showed all the parts were the same, all the matching parts. And if all the matching parts are the same, that means they have to be congruent triangles. It doesn't work just on triangles, but we use triangles the most. Okay, so remember there was like 6 pairs of facts, like 3 pairs of angles have to be congruent, and 3 pairs of sides that have to be congruent. Okay, but there's actually an easier way to prove two triangles are congruent. And let's see if I can draw this, all right. Let's say these two triangles are congruent. You guys remember what these marks mean, right? These two are the same. Arcs mean these two angles are the same. Okay, this is actually enough information to know that the entire triangles have to be congruent. Because if you think about it, if this angle is the same as this one, and you draw a line the same length as you draw this line, and you draw this line the same length as you draw this line, this third line is going to have to be the exact same length, right? And these angles will have to be the same too. So this is actually enough information to say these two triangles are going to be the same. You don't have to say all the sides are the same, all the angles are the same. This is called side, angle, side congruence postulate. Basically, triangle congruence postulate. We're just going to call it side, angle, side. Okay? The angle has to be, yes. The angle has to be right between the two sides. The book calls this the angle is included between the two sides. So if we had something like this, that does not count. Okay? Even though they have congruent parts, this actually is not enough information to know that these two triangles are congruent or not. If this one was moved out farther than this one, they'll be different. Anyway, this would be side angle, not side angle side. So this is a no-no. This one also makes a bad word, or it's a donkey. So angle, side, right?
Oh my God.
So if it makes the bad word, that means it's not the right. It's a no-no. You can't use that one. That's not congruent. All right, SAS is good. Side angle or angle side. It doesn't work. It doesn't work at all. Okay, there's another one that works though. Actually, there's like 5 that work, but we're only doing 2 of them today. Doing a few at a time. Okay, let me draw. I'll do those right triangles again. Say that's the same, and we'll say that's the same. This is actually enough information to say that triangles are congruent also. Does anybody want to guess what it's called?
Angle, side angle.
Angle, side angle.
Yeah.
You guys know how I figured that out? Girls, pay attention. So on this one, the side has to be between the two angles. So if it looked like this, that would actually be angle, side. Which that actually does work. And we'll talk about that tomorrow, but we're not using that one today. But this would be called angle, angle, side. This is angle, side, angle. We are using the side. You guys see the difference? On this one, the side is included between the angles. That just means it's between. On this one, the side is not between the two angles. Angle, angle, side. I guess you could call it side, angle, angle. And actually, I don't remember which one this book uses. Different books use different ones. So you might say angle, angle, side. You might say side, angle, angle. If you wrote down either one, it would be okay with it. That's tomorrow's, so it's not wrong, but we're not doing it today. All right. One last thing I need to mention. Let's say that we knew these three things, like these are congruent, these are congruent, these are congruent. If that was true, then I know for sure, let's say these sides have to be congruent. How do I know? Why do I know that if they didn't tell us? Okay.
Because there is space between those two.
No. It's because this right here is enough information for me to know the entire triangles are congruent. So if I know the triangles are congruent, I know any of the matching parts, any corresponding parts are congruent. So I know, if I know the triangles are congruent, I can say, well, those two have to be the same, or those two have to be the same.
Because if the angle is any different, then it'd be.
Or these two sides have to be the same. So once you know the triangles are the same, you can say any other parts have to be the same. So these three things are enough to say the triangles are congruent by angle, side, angle. Then after that I can say, so this is congruent to that, or this is congruent to that, or this angle is congruent to that angle. Because they're corresponding parts of congruent triangles. They have to be congruent. So that's pretty much it. Not a lot today. So page 165. Montana, this is where I write the assignment. Just put your name and the assignment down in the corner. And typically I do the odds with you guys. The odds also happen to be in the back of the book. I said that. I'm a liar.
Whoa!
Yeah.
I feel like you can tell if we
Okay. Are you a sophomore? Okay. Number 1, name the included angle between segment AD and segment DC. Okay, you guys see AD and DC? You should be looking in your books, Dylan. Wake up.
Angle D.
Okay, what angle is between segment AD and DC? Okay, you cannot call it angle D. You guys know why? Because there's 3 angles that have D as a vertex. There's the little angle on top, the little angle on the bottom, and the big angle. So you gotta be more specific, yes. Tristan said angle ADC. Yeah, that would be number 1. So, angle ADC. What's another thing we could call angle ABC? CDA. So if we grade it and I say it backwards, you need to know that that's the same thing. Number 3, name the included side between angle DAE. You guys see that in the picture? If you don't see it, just trace it with your pencil. DAE and AED.
Line segment AE, yeah.
Yeah. If you look, yes, in the upper left corner, in the middle, top middle angle. Yeah, segment AE is between those two. Hopefully you saw it. Is segment AE the same thing as segment EA? Yes.
Wait.
The segment from A to E is the same thing as segment from E to A. Oh, yeah, I forgot. We're not actually doing 5 and 6. 5 and 6 means use a protractor, or actually a compass to draw that. We're not going to do that. So, number 7.
So the assignment's actually 1 through 4, 7 through 18.
Yes.
24.
Yes. Yeah, I didn't change it. Okay. So the directions. If the triangle can be proved congruent using side angle side congruence or angle side angle, I'm just going to call it SAS or ASA. Write a valid congruence statement and name the postulate that justifies it. So we might say like triangle ABC is congruent to triangle XYZ by side angle side or something like that. If we know the triangles are congruent. If not, state an additional side or angle congruence that would enable the triangles to be proved congruent. So for example, if they only give us side angle, then we need to say, well, if we knew these sides were the same, then we would know side angle side, right? Or if we knew this angle was the same, then we could use angle side angle. Does that make sense? So if we have enough information to say the triangles are congruent, we're supposed to say they're congruent by side angle side or angle side angle. If we don't have enough information, we need to say what extra information would help us get there. Number 7, do we know those triangles are congruent?
Yes.
By what?
SAS.
Side angle side. Yeah, if you look at it, we know the sides, the angles, and side. You gotta look at both triangles because sometimes they do side angle side on one triangle and then side angle on the other, and that doesn't work. But yeah, we do know. Okay, so we gotta say the triangle congruent. So this is like what we did on Tuesday. So say like triangle, you just choose the order of the first one, ABC. But the second one, remember you need to line it up correctly. You don't have to say ABC, you could say BCA or something.
And then you put.
Okay, what does A go with on the right triangle?
E.
E. What does B go with on the right triangle? F.
And then D.
And then D is left over.
So yeah.
So notice it's not in alphabetical order. ABC is, but this one's not. All right, and then how did we know that? What theorem postulate did we use? SAS, side angle side.
Are they connected?
Okay, number 9. So all the angles are congruent on both triangles. Is that enough to say the triangles are congruent?
Yeah.
No.
No.
There is no angle. So I could draw a really tiny triangle with like 60-degree angles and a really big triangle with 60-degree angles, right? Just because their angles are the same doesn't mean they're congruent. So I can't say the triangles are congruent. What fact, if I knew was true, would make those two triangles congruent?
One of their sides.
One of their sides. Yeah, there's actually 3 possible answers. We only need to write one of the answers. So what's a pair of sides that, if they were congruent, would work?
GHLM.
Okay, yeah. Doesn't really matter which two you choose, but GH is congruent to LM. That would be enough information to say those two triangles are congruent. Do you guys know why?
Because then that'd be side angle.
Yeah. Because if I knew these two sides were congruent, I would have angle, side, angle. Angle, side, angle. You don't have to draw that. This is the answer right here. There were 3 possible answers on that one. You just have to list one of them. Number 11.
No.
Do we have enough information to say those two triangles are congruent? It's kind of a trick question. Okay, we did a proof on Tuesday. You see that side that is shared in both triangles? You guys see AC? We know for sure that side is the same in both triangles, right?
So it'd be angles, very side angles.
Yeah, so there actually is another side that they don't mark. So there is a side angle side. Do you guys see it? You know what I'm talking about?
Yeah.
Guess I can draw it. So they drew in that and that, and they drew in that and that. But we know this is the same in both triangles. They didn't mark it, but we know it has to be. So yeah, it is side angle side, side angle side, So triangle, somebody help me out here.
DAC.
DAC is congruent to triangle
BCA.
BCA. Yeah, see how it's rotated 180 degrees on the right triangle? So DAC would be the same thing as BCA. Smart words started to get not so smart. Okay, and which postulate did we use? We used side angle side again.
What's the bad third?
Well, yeah, 13 is the bad word you said. So, you guys see 13? Oh, before we do 13, on number 12, what do we know is congruent in those two triangles that they don't give to us?
L and M, or J and N and L and M.
Huh? What? Okay, angle JKN and LKM have to be congruent, right? Because they are vertical angles. So even though they don't tell us, we know those angles are actually the same. Kind of like on 11, we knew that line down the middle had to be the same in both triangles. Okay, 13, so it's side-side angle. Is that one of them? Is side-side angle one of our postulates? No. So we don't have enough information to prove it yet. So what additional information, there's a couple possible answers on this one. What additional information could we use to prove they were congruent?
Angle H and angle L.
Okay, yeah.
If any of those angles.
Yeah, angle H is congruent to angle L would be enough. You guys know why?
Side angles.
Yeah, because it would be between those two sides and then we could use side angle side.
You made that look weird.
Or, actually, on the bottom we would also have angle side angle, wouldn't we? If we had the bottom right angle, we'd have angle side angle along the bottom. So, yeah. Or another way we could have done this is if we knew GF was congruent to KJ, those left sides were congruent, we could have used side angle side. Yeah, the angle symbol kind of looks like my L, but
Can you do 14?
no.
Okay.
14 is like 11, it's got a shared side, but there's still not enough information. 15. Are those two angles in the bottom middle, are they the same? Do we know for sure they're the same? No, we do not. They are not vertical angles, like number 12, because they're not on the same lines. Do we have enough information to say 15, those two triangles are congruent? No, all we got is angle side, or side angle. So somebody besides Will, what other fact could we use to say those two triangles are congruent? Archer?
CA is congruent to RA.
Yeah, those two sides, there's more than one possible answer on this again. But yeah, if we knew CA and RK were congruent, then what would we have at that point? You guys see
Side
it?
angle side.
Yeah, we would have side angle side. Yoink. Okay, 16 and 17 say both mainsails on the sailboat in the photograph form a 90-degree angle with the main mast. I think the mainsails are the ones with where you can see the flag on top a little bit better. Not really a sailing expert, but I believe that's what they're talking about. So like, these two are the mainsails, the ones that look like that. They're saying it forms a 90-degree angle with the mast. The mast is the thing that holds the sails up, this big wooden thing in the middle. Here's my boat. Banana boat.
It does look like a pumpkin. I can't
I
I can't unsee it.
Oh no, it does.
Can you like draw this the pumpkin around it real quick?
This is efficient use of our time.
Happy Halloween.
I don't know if we got it.
I'm so happy.
That is it?
Trick or treat.
No. I don't.
That's close, that's close enough. That is close enough. The darker one is
There you go.
Thank you.
Thank you. You gotta do the little stem on top.
They didn't really make any.
You can do this, doesn't, do a little like.
You can fill it in with like yellow, so then it's pretty green. Actually, I'm pretty happy with that.
It needs now it looks like.
Okay, we're gonna hold that.
It needs tea first.
All right, 17 says, if you know the height of each cell is the same. Okay, so what should I mark the same then? Yeah, the height would be like, if you have a line that's perpendicular to the ground, that's basically the height of the thing, right? If you have a line that goes straight up, that is the height. And it also says the bottom of each sail is the same. So that would be these two guys, right? All right, the question is, can you be sure that the third sides have to be the same? Third- Okay, why? Explain. He says.
Because it's ASA.
Okay, because the triangles are congruent by
Side angle
side, angle, side. And then that's the first thing we're gonna say. And then if the triangles are congruent, the corresponding parts have to be congruent. Corresponding parts being any matching parts. And we're talking about the third side. But anyway, so I'm gonna say yes by side, angle, side. The triangles are congruent. And then if the triangles are congruent, any corresponding part. In this case, the third side of the triangle, any corresponding part must be congruent. Can I write out a review?
Oh, got the symbol.
All right. In the future, when we put this, we'll need this line for a proof. We're not going to write the whole sentence like this. Okay. So basically, the sentence is corresponding parts of congruent triangles have to be congruent. But instead of writing all that, we're going to write this. Corresponding parts of congruent triangles
This is way
are
longer.
congruent. The first time I wanted you to write it out. But in the future, we're going to start using this. Corresponding parts of congruent triangles, they have to be congruent. So if they ever ask us, how do we know that side is the same? If we already said the triangles are congruent, we can say Cpct, corresponding parts of congruent triangles. But for this one, I just wanted you to write it out. Huh? Okay, I will help you on 18, but I'm not going to write it down so you can pay good attention. Guess, it's a fill in the blank proof. So guess what goes on line 1?
The figure.
Okay, nope, you're not going to write the figure.
No, like draw it.
No, do not draw it. What is the given?
B figure. C is the midpoint.
Okay,
The parallel lines.
you're looking at 19.
Oh, whoops.
Okay, yeah, Marion got one. So,
AB is parallel.
one of the things that is given to us in the picture is that line AB is parallel to line ED. You guys remember the parallel symbol, right?
It looks like. Yes, the.
It looks like,
Wait, we didn't do 17.
looks kind of like an 11, right?
We didn't do 17, did we?
We did 17, not 16. 16 is very similar to 17. now. This was 17. I skipped 16. 16 is very close to
I
17.
thought that was the thing.
That was 17.
You want option to erase 16 and put it in 17's fine. Yep.
So you said that AB is parallel to ED?
Yes, that's what those red arrows mean. Remember that?
Yeah.
What else do we know from the picture?
AC and CD are congruent.
Okay, yeah, those red lines tell us AC and CD are congruent. So on the given line, you should also write AC is congruent to CD. Have you done these before?
Air conditioning and
Uh-oh.
CD.
Trouble.
I say we skip this problem.
No, we're not skipping.
It's freezing in here.
Is it?
is.
Well,
It's so
it is
cold.
not.
Okay,
It's
let's
so cold.
let's close the
AC
bin.
is congruent to CD.
I also just don't have it.
Can
It's
you
freezing.
close that bin?
It's freezing.
AC is congruent to CD.
I'm very like
So actual parallel is AC is congruent to
cold nature.
CD.
CD.
Just look, they tell you, just look at the picture.
What's AC?
Look at the picture. What's AC congruent to? Yes.
It's so much more.
Wait.
Oh, I'm smart.
Okay. Line 2 says vertical angle theorem was the reason that they could say the first part. So guess what they said in the first part? Somebody besides Archer and Will. Yes, you guys hear that?
Angle.
Okay. What are the vertical angles in the picture?
AD.
Those are not angles.
What'd you say?
ACG is compared to BC.
AC.
Okay. Vertical angles are angles that are created when two lines intersect, right? The angles across from each other are always congruent. They're called vertical angles.
ACB.
Yes. Angle ACB is congruent to angle ECD.
ACB figured to what?
Look in the picture. That helps. You're not supposed to be memorizing what I'm saying. You're supposed to look at the picture to
I am looking at the photo.
understand what I'm saying. Okay, we're not done. Hold on. Darn it.
Oh, that just means that.
Okay, so what we just said was those two angles are the same. Do we have enough to say the triangles are the same, are congruent yet?
Not yet.
No, all we have is side angle, right? So we need one more. The line 3, the reason they say you can say line 3 is alternate interior angle theorem. You remember alternate interior angles from chapter 2?
Yeah. Sadly.
Okay, when you have two lines that are parallel, gosh, the board's starting to mess up, and a line crosses them, these were called alternate interior angles right here. Remember that? And they had to be congruent if the lines are parallel. So on this picture, do you guys see it?
BA, angle BAC and
Yeah.
EDC.
Well, we don't need that many letters. And if we knew these were the same, then we would have what? ASA, right? AS, angle, side, angle. Do we also know these are congruent?
Yeah.
Yeah, but that would give us angle, angle, side, which is not one of our postulates. So we're not going to say this one. We're just going to say this one. What are these two angles called in the picture?
Angle A, BAC and ED.
It's just angle A and angle D, right?
But you said, I thought you told us not to put angle, blah, blah, blah. You had to give like all 3 letters.
That's because there was multiple angles on that last picture that we did that.
Nice.
So if there's just one letter up, or one angle up there, you can just call it angle A and angle D. So angle A is congruent to angle D. All right. Line 4 says, therefore the triangle blah 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 is congruent to triangle blah blah. Right. Angle, side, angle. ASA.
For,
If we put an N in it, that means ASA.
Yep.
I thought of that.
24 or
Yep.
4's reason is
Any tips for 24?
Okay, for 24, we're not gonna do a paragraph proof, we're gonna do the standard 2-column
Number
proof.
4 was angle
Is that what we just did?
Yes.
A.
The paragraph proof is saying, just kind of saying it more
What's number
like
4?
conversationally. But we're gonna stick with the 2-column proof.
How many steps do we have then?
I think there was like 4. Okay,
No.
actually, no, there was like
Not
3.
number 4. It was angle A.
No,
It
4,
was
4.
congruent to what? What was angle A congruent to on 4 on 18?
Look, right here, these 2 angles are congruent.
Okay, to D. Yeah, got it. Thank you.
All right. 24, we are going to, shh, girls. We're going to write our own 2-column proof. So what do I need to do first?
Find the given.
Well, first I should write
Statement
statement and reason, just like the last problem wrote for us. Okay, the number 1 reason is always going to be, so, but we need to figure out what is actually given to us on that problem.
A picture.
Good one.
Okay, what is information we know right from the get-go?
When EA is congruent to DC.
Okay, EA is congruent to DC. But wait,
Angle A is congruent to angle C.
angle A is congruent to angle C. Just by looking at those red marks, we know that. There's one other thing, actually. B is the midpoint of AC. That's important.
Whole thing.
Okay. That was all line 1 because all that stuff was given to us.
Okay.
So the last thing, B is the midpoint. That was not in the picture. They said it in the problem. They told us that if you read the problem. All right. What we're trying to get to is we're trying to say that angle E and angle D are congruent. That's what it tells us at first. You guys see angle E and angle D in the picture.
Yeah.
What method, based on the lesson today, do you think, how are we going to prove those 2 angles are congruent?
Honestly, no idea.
What have we been doing today?
Sine angle sine.
By figuring out what the both angles.
Okay, we're going to prove it by proving the 2 triangles are congruent. If I knew the 2 triangles are the same, then I know their parts have to be the same, right? Similar to what we said on number 17. So,
We just need to figure out that AB.
so far, we've already got a side and an angle, right? We've got a side and an angle. They drew it in the picture for us. So I need like another side or another angle or something. They told us though that B is the midpoint of AC. If B is the midpoint of AC, quiet will nurture, and canyon. If B is the midpoint of AC, then what else must we know? Look at the picture. If B is the midpoint of AC, what else must be true?
Oh,
That it's the midpoint.
angle EVA and C.
Nope.
Oh.
It's congruent. It's a,
If do you guys see B in the picture?
Wait, that means that what's it called? B and D and E and B are congruent.
Okay. EB and DB, no. B is not, no. B is in the middle of AC. Well, I'm not going to call it names.
That means line AC.
Yeah. If this is in the middle, what do I know? These 2 are the same, right?
Yeah.
If it's in the middle? So what are these called in the picture?
It'd be angles.
This is what in the picture? Sadness.
The base.
What's this called in the picture? Archer, look over there.
This is
Or
the
Katie.
base.
ABC.
What's this in the picture? AB. What's this?
AB is congruent to BC.
BC.
I got it.
Okay, AB is congruent to BC.
Didn't think you were going to.
Does that make sense?
Sorry.
It's not supposed to be a trick question. If B is in the middle, we know those two parts have to be the same.
I said it's congruent.
Oh, but how do we know that though?
Definition of midpoint.
Because
Definition, because that's what midpoint means. So it's called definition of midpoint. If your answer is like, because that's what midpoint does, or that's what it is, the answer is definition of midpoint.
Okay.
Do we have enough info to say the triangles are congruent yet?
Yes.
I should. We have. We just said that was the same, right? The book told us that was the. Wait, which parts did they tell us? They told us these were the same, and they told us these were the same. So by what do we know? Side angle side. So we're ready to say that triangles are congruent by side angle side.
Is that the reason or the statement though?
No, that's the reason. We're saying the triangles are congruent. How do we know they're congruent? Side angle side.
Side angle side.
So triangle, help me out here.
Triangle.
Triangle congruent.
Will.
EBA is.
Well, you have to raise your hand to get called on. I probably won't call on you either.
Is congruent to DBC.
Okay, that'll work. EBA, DVC.
DBC.
And what was the reason?
Sass.
SAS.
I forgot. It was like 3 seconds ago.
How can you forget short-term memory loss?
We're still in Marianne's glory. All right, that's not actually what we were trying to prove, though. What we're trying to prove that those angles on top are the same.
So there's more.
So how do I know the angles on top are the same?
Can I say it? Keep going to stretch. There you
Candy.
go. Cpct.
Right. If the triangles are the same, the parts are the same. It's called Cpct, corresponding parts of congruent triangles. So I'm going to say what we're trying to prove. Angle E is congruent to angle D because they are corresponding parts of congruent triangles. If you don't remember what that means, you'll never know when to use this. Corresponding parts of congruent triangles.
Yeah.
I'm done.
I'm
You're
done.
not done.
No, I'm done.
Well, I just have two.
Then do those right now.
Do you need to